Hi everyone. Today I come back with section 7.4 addition and subtraction with unlike denominator. Remember that last time I have talked about 7.3 addition and subtraction with like denominator. So what does that mean? We did learn something like if A over B plus or minus sorry, let's say A over C better, B over C, then you can just what you do is you can just have the top, do the operation of the top and keep the bottom stay at C. So that is for the case that denominator are the same. What about today we learn about the case with denominators that are not the same. So what you should do is in that case, let's say I have A over B plus C over plus or minus D. Then what you should do? Okay, usually you're going to try to make uh, something um, um, to make it become the same denominator, right? So you would like to may have like B times D uh, and A times D for the first term. So the first term I multiply by D, both top and bottom, and then the second one I'm gonna have C times B divided by B times D. Actually, I'm gonna say D times B because I multiply by B for both top and bottom of the second term. So why I do that? Because now you can see I am having the same denominator, and then later on I can follow the same rule from the addition and subtraction with like denominator. So it's mean what? It means that you will try to convert the two term become two fraction that have the same denominator. So you can using the addition and subtraction with like denominator. Okay. So let's do an example. Um, let's say example 1 over 6 plus 1 over 8. Okay, so what you do is um, you can think about trying to make is both of these terms having the same denominator. I know that if I multiply top and bottom of the first term with 4, so 6 times 4, and I add with the second term multiplied by 3 both top and bottom. Remember that when I multiply like this, then the value of the term stay the same because like 4 divided by 4 going to be equal to 1, and 3 divided by 3 is still going to be equal to 1, and 1 multiplied by the fraction should stay the same, right? So now if I change it is if I simplify it or I gonna say if I multiply it, I'm gonna have the first term become 4 over 24, and then the second one gonna be what? 3 over 24. And now you can see that I'm having the same denominator for both for both this term, right? And then now I'm gonna just adding 4 and 3 and keep the denominator as 24, and that's gonna be 7 over 24 as the answer. So, what happened? How can I know that the first term should multiply by 4 and the second one should multiply by 3, right? How can I do that? All right. So that's that means you will have to learn a method called finding least common multiple. Okay, so finding the least common multiple. So we can also notate it by LCM. Okay. Some people can also call this method as find the least common denominator, right? And it's called like LCD. Okay. So let me tell you that the 3-step in to find the least common multiple, right? So step 1, you're gonna factor completely, factor each polynomial completely. Step 2, you're going to list each factor the greatest number of time. Okay, so list, let me see. List each factor the greatest number of times that occur, that it occur. Oops, what happened? Occurs in any factorization. Okay. And step number 3, you're going to find the product of the list. A factor. So the result will be LCM. Okay. So yep, that is the way. Okay, so let's come back with the example 1 out of 6 plus 1 out of 8 over there. In order to find the LCM of 6 and 8, what you do is let's list out 6 and 8, factor of them, right? You will have what? 2 times 3 for the 6. And for the 8, what you do is you have 2 to power third, or I mean, yeah, you can write it 2 to power, or maybe you can write it this 2 times 2 times 2. Yep. So if you write as 2 times 2 times 2 over there, what does that mean? If you combine it, it's going to be like 2 to the power third. Why I write like this? Because it's in the step 2, in step 2 over here, it's a list each factor the greatest number of times. So in here, for the factor number 2, right? The greatest number of time which is 2 to the power third, right? So so it means it's appeared 3 times, and then I just have like 2 to the power third, and the second factor gonna be number 3, right? So number 2 have 3 times, which is this one, and number 3 is there's only 1 over here, so I have 3. So when I have that, I just multiply to this factor, and I will have what 8 times 3, which is 24. That's going to be the least common multiple of 6 and 8. Okay, so let's do some another harder problem and see what happens, right? So now let me have another example. Let's say find least common multiple, or someone called least common denominator. Okay, so for A, if I'm looking for 2x comma 5x squared, right? Okay, so let's be list 2x and 5x squared, right? 2x will be equal to 2 times x, and 5x squared going to be equal to 5 times x squared, right? So least common factor will be, okay, now the first factor is number 2. How many times the greatest? Okay, so let's come back with step 2 here. The factor number 2 have the greatest of time that it occur is only 1. So this guy, right? So put 2 only. I also have 5, and the greatest is only 1 time. Greatest times occur, so it's only 1, so it's 5. And now for factor is x. What is greatest time factor x occur? It actually 2 over here, right? So I put 2 here, right? X over 2 here, right? And that will give you 10 times x squared. Gonna be the least common multiple. Okay. Let's have another one. Let's do x squared plus 2x plus 1 and x squared plus 3x plus 2. Okay. For these two, they are trinomial, right? The first one was like a special case with perfect square formula. You can try to remove it, but I show it x squared plus 2x plus 1. When you factor it, you're going to have x plus 1 times x plus 1. And for the x squared plus 3x plus 2, you may have to use the AC method I showed you last time. Or if you still remember in chapter 6, how to factor, you know that a times b, sorry, a times c, in this case was 1 times 2, which is 2, right? And a and b in here was number 3. Okay, so you need to looking for two number, excuse me, two number multiplication gonna be equal to 2 and addition equal to number 3. Okay, so now you have 2 and 1, right? And remember that in this case a equal to 1, so I have x plus 2 times x plus 1. Okay, now we did have the factor of each expression. What we need to do is let's have LCM by by list out all the factor with the greatest time appear. So for the first for the x plus 1 the factor x plus 1, how many times it appear? You see for the first expression you have 2 factor x plus 1, right, which equal to x plus 1 to power 2. So that's going to be the greatest time appear of factor x plus 1. And then you multiply by the other factor, which is x plus 2, and this have only one time appear. And that's going to be the LCM of these two expression. Okay, so finally I think we have we can have enough information to let me see 1 second, enough information to handle the adding and subtracting the problem, the fraction, the rational expression with unlike a denominator. So let's do example number 3, which we're gonna do adding and subtracting stuff. So let's have a with 3 out of 10 plus 4 out of 15. So in order to do this problem, I would like to have a side work. Okay, side work. I have to find the LCD, which is find the LCD up to this fraction, right? 310 and 415, right? So which mean you are looking for the LC, the least common multiple of 10 and 15, right? Because that's those they are the denominator up to this fraction. So you know that 10 can be equal to 2 times 5. And 15 can be rewrite as 3 times 5, right? So the LCM or LCD will be equal to factor number 2 have only one time, factor number 5 have only one time, right? Only one time appear for each case here. So and even though it looks like you have like number 5, but it just this number 5, it just appear one time for each number, right? So it's still only 5, right? Or we have like a common factor, and it said that only on number 5, and this number 3. So this common multiple gonna be equal to 2 times 5 times 3. What is that gonna be? 30. Okay. All right. And if you want to go by the listing step, you can go like this. So so list all the common factor in the same column. So when you for the least common multiple, you can just put down the common factor, and all the other one doesn't have any common factor, then just put it out, and then you're gonna have 2 times 5 and 3, which is 30. Okay, so now come back with the problem here. I have the first term was 3 times 10, right? 3 times 10, and in order to make is the number 10 become 30, I need to multiply it by 3 at the bottom, right? And in order to make it consistent, I need to have multiplied by 3 for the top also. So so then I don't change any value of the first expression. Okay, adding with 4 times 15. Yeah. So now the 15 need to multiply by 2 to get 30, right? And then I also have to multiply by 2 for the top. So now you have 9 over 30 plus 8 over 30, right? And finally, the answer should be 9 plus 8, which is equal to 17 divided by 30. That should be the answer, right? Adding the top, keep the bottom. Okay. Let's do another one. So say B, I have 7 over 8 minus 1 over 6. If I do side work, right, I have I need to look for the LCD, right? So I have 8 will be equal to 2 times 2 times 2, right? Let me try by the listing step. So 6 gonna be equal to 2 times 3. Okay. So in order to make to use a listing step, you don't gonna have the if you have you have different factor, they should not have the same column. So put 3 in the sign over here. So now the LCD will be equal to this common factor, then it should put 2, only 1. And then this one doesn't have anything, so put 2. This one also doesn't have anything common, so 2. And then number 3. And then you will have 2 times 2 times 2 is 8 multiplied by 3. It's going to give you 24. So now come back with this one now. You have 7 over 8. In order to make it to become number 24, then you multiply it by 3. And also have to multiply by 3 for the top, minus 1 out of 6. And in order to make the 6 become 24, then you multiply it by 4. and also multiply by 4 for the top. And now if you do multiplication, you have 21 divided by 24. Yep, and minus for the 4 divided by 24. So finally, you will have 21 minus 4 going to be equal to 17 divided by 24. That should be the answer. Okay, now, so what happened? This is just very basic, basic adding things. Now, what happened with what happened if we have to adding, we have to add rational expression. Right. So let's do but see. If I have 5 over 8y plus 7 over 4y squared, right? So let me also gonna use the listing method over here. So I have denominator for the first term was 8y, second one is 4y squared, right? So I have 8y gonna be equal to 4. I can write it as 2 times 2. Okay, let's rewrite factor it completely and then times y, right? 2 times 2 times 2 times 2 times y, right? And then the second one will be 2 times 2 is 4 times y and then times another y. Okay. Now LCM or LCD will be what? Equal to common factor will be, oops. Common factor will be number 2. Another common factor will be only number 2. And then this one doesn't have, so number 2, common factor y, then you have only one y. And then another y that doesn't have any common factor. So this, if you simplify, then you're going to have LCM equal to 8y squared. Okay. So now come back with the problem. I have the first term was 5 times 8y, but I want to make it become y squared, right? 8y squared. I want to make it look like that. So what should I do? I need to multiply by another y to make the y squared, right? So since I multiply by y, then I have another multiply by y for the top and so. And then I plus with 7 over 4y squared. So, to make this 4y squared become 8y squared, then I have to multiply that by 2, so 2 here. Then that should be 5y plus 14 divided by 8y squared. That should be the answer. Okay, let's do another one. D. If I have x over x squared plus 2x plus 1, and then plus 1 over x plus 1. Okay. Let me move it up a little bit. So another side work. I have x squared plus 2x plus 1 will be, it is special case, right? You can just write we have x plus 1 squared. And then before doing that, you need to have parentheses here, right? So then the other denominator will be x squared, not x squared, sorry, x plus 1. And actually, x plus 1 have just x plus 1. Yep. In this case, I would say like LCM will be just the factor x plus 1. We have 2 terms appear from the first term, okay, from the first expression. So LCM should be x plus 1 squared. Okay, so now I will change the first term to be x over x plus 1 squared plus with and I don't have to change anything for this one because why? I don't have to multiply anything for this one because I actually have the denominator is exactly LCM already, right? So what I do is for the second one, I need to change something to make it become x plus 1 squared. I actually need to multiply it by another x plus 1. Similarly, I need to do multiply for the top with x plus 1. So then now it will be equal to x plus x plus 1. Because 1 times x plus 1 will be just that, right? And then bottom will be x plus 1 squared. All right. You know what? I'm gonna move this to the left hand side so I have more space. I'm gonna move here. So x plus 1 divided by x plus 1 squared. Okay, now you can see that in front of the parentheses have like an addition, right? So you can just take away the parentheses and you're gonna have x plus 1 and divided by x plus 1 squared. So lastly, if you combine like term, x plus x will be equal to 2x plus 1 divided by x plus 1 squared. And that should be the answer. Okay. Let me see if I make any mistake. Just want to make sure. Okay, that's good. All right. Let's do a subtraction example, right? What's the next one? Yes, E. So if I have Let's do a very complicated one. 3 times x minus 1 minus 3 times x square minus x, and then plus 5 out of x. Okay, now what? You have 3 denominator, right? Let's list out all those 3. I have x plus x minus 1, sorry. X minus 1. I have x squared minus x, and I have x. Let's try to factor it. So the first one was just x minus 1. The second one, now you factor the great common factor. It's going to be x multiplied by x minus 1 in parentheses. And then the last one is just x. Okay, so you see that there is common factor. Big group over here is gonna be, so LCM now become x minus 1. And then x here also gonna be only x. So that's gonna be the LCM equal to x times x minus 1. So you need to you need to convert the denominators be x times x minus 1, right? So the first term I have 3 times divided by x minus 1. You need to multiply by x in order to make it look like LCM. So top and bottom multiply by x minus 3. For this one, you can factor it and it becomes x times x minus 1, which is exactly the LCM already. So I don't change anything for this term, and I add with the 5 divided by x. Okay, so this actually need to have x minus 1. Factor x multiply with the x minus 1 in order to have the same numerator. So now finally you can have 3x minus 3 and then divided a plus with 5 times x minus 1. I keep this one because I think we may gonna have to use that later. Let me see. You know what? I'm gonna just keep it as 3x minus 3 and then add with 5 times. I'm gonna reduce this minus 5 divided by x times x minus 1. Now I'm gonna have combined term 3x plus 5x gonna be 8x. Negative 3 minus 5 gonna be minus 8 divided by x times x minus 1. So you factor it. Let me see. If you factor the 8 out, you have x minus 1 divided by x times x minus 1. Okay. Did I miss any things? Let me make sure. And lastly, you can just cancel the same factor that will just give you a x. Okay, so that should be it. Yeah. So let me see. Anything else I need to? Yep. So that should be all for this section. And if you have any question, I will see you in the class. All right.